In this lesson, we are going to be writing a recursive rule for an arithmetic sequence. We are going to be able to write the explicit rule for the arithmetic sequence, and then we're going to be going from one form to the other. So let's review. Remember that an arithmetic sequence is a sequence where each term changes at a constant rate. For example, when we have our first sequence listed, we are going from 5 to 8, 11, 14, and 17. Notice that we are adding 3 each time to get to the next term. When we take a look at the one below, when we're going from 10 down to 5, down to 0, down to -5, and so on, we're subtracting 5 each time. Over here on the right, we have some examples of sequences or patterns that are not arithmetic sequences. For example, when we take a look at this, we're actually multiplying by 2 each time, so that is not an arithmetic sequence. So let's review the definition of the explicit rule. The explicit rule is where we are given a formula or equation that allows us to calculate any term in the sequence. So a to the n stands for any term that we're looking for. D stands for the common difference. N stands for the number of the term that's in the sequence. And a sub 0 stands for the term before the first term. Now we're going to move into something called the recursive form. And the recursive form, we want to know what our first term is. And then we look for a to the n, or whichever term we're using in our sequence, and that equals the term previous to that. So if we were talking about the third term on a to the n, then this would be the second term plus the difference. This is called the recursive form. So if we take a look at the examples that we have listed, 7, 11, 15, 19, and so on, the first thing we want to do is we want to find the common difference. So when we take a look, we can see that as we go from one term to the next, we are adding 4 each time. So our difference is 4. Our first term is our a to the 1 is 7. And now when we're writing the rule, we simply go a to the n, meaning whichever term I am looking for. All I do is take the previous term, a to the n minus 1, and I am going to add the difference. The difference in my sequence is 4. Let's take a look at the next example. So I have 7 over 2 to get to 3 over 2 to get to 1 over 2, -1 over 2. So it looks like if I look at only the numerators, I'm taking away 4, and I also have a common denominator, which is 4 over 2. So my difference is -4 over 2, or I can write it as -2, simplifying that fraction. So to write the recursive rule or the recursive form, the first thing I'm going to do is write down my first term, which is 7 over 2. Then to write the rest of my rule, I write a to the n, which means whatever term that I want to find, all I have to do is to take the previous term, and in this case, I'm going to subtract 2. I need to write that just a little bit better. I want to make sure that my a to the n minus 1 is down in my subcategory. So it's n minus 1 down here, and then I'm subtracting 2 to get to my next. Alright, so let's do some examples. We are to write the first 4 terms of the sequences given to us. So if I have my first term, which is -2, it tells me to get to any of the next terms, I simply have to add 3. So if I start at -2 and I add 3, I get +1, and I add 3 and I get 4, and I add 3 and I get 7, and that's how I will get the first 4 terms of my sequence. In the next example, my first term, or a sub 1, is 4.5. Then according to my rule, to get all my other terms in my sequence, I simply have to add 1/2. So if I have 4.5 plus 1/2 would give me 5, plus 1/2 would give me 5.5, and plus 1/2 would give me 6. So let's take a look, and what we're going to be doing is given, we want to write the explicit rule for the nth term given the recursive rule. So here's the recursive rule. It says that my first term is 18, and to get to all the rest of my terms, I'm going to add 4. So my d is equal to 4. Here is the recursive rule as you recall from our previous lesson. What we need to do to write the rule is have a to the n, and that equals the difference, which is 4, times the number of the term we're talking about, plus the term before our first term. If our first term is 18, and I'm going to subtract 4 each time, or excuse me, add 4 each time to get my next terms, I would like to back up a term. So instead of adding 4, I'm going to subtract 4. So that means my a sub 0 is equal to 14. Let's take a look at this example. So my first term is -9. To write my explicit rule, I have a to the n equals my difference, and that's located here in my recursive rule, which is -12. So my d is a -12. So I have -12 times the term that I am on, which is n, plus my a sub 0 term, which means I want to know what happened before -9. So if I want to start at -9 and write all the terms in order, I'm going to actually subtract 12 each time. But if I want to back up a term, that means I'm going to do the opposite, which is I'm going to add 12. So -9 plus 12 would mean that my term before would be at a +3. So that's going to be my a to the 0 term. So I'll put that on the end of my formula. Let's take a look at some other examples. Can we go the other way around? This time I'm going to be given the rule, and this is the explicit rule, and I want to write the recursive rule. So the first thing I look for in my formula is my d. So d is equal to 6. So if I'm going to write the rule, I have to find my first term. Remember that this 2 is my a sub 0, and my difference is a +6. So all I need to do is to take my 2, my a sub 0, or the one that I have before, and I simply need to add 6 to that, and that's going to be my a sub 1 term. So my a sub 1 is equal to 8. So now I want to write my recursive rule. And the recursive rule is a sub 1 is equal to 8. The rest of my rule will be a sub n, or whichever term I want, is the a sub n minus 1, or the previous term, plus my difference. My difference is 6. Let's take a look at this example. Remember, the number in front of the n is my difference, so my difference is going to be -2. The number 8 is my a sub 0, but that's the term before my first term. So all I need to do is to take the 8, which is my a sub 0, and I need to add the difference, or -2. That means my first term is going to be at 6. So to write my rule, I have a sub 1 is equal to 6, and then I have my a sub n, and that's equal to my previous term, a sub n minus 1, plus the difference, and my difference is -2, so that will be finishing my formula. Let's take a look at a couple of more examples. So now I want to write both the explicit and the recursive rules for the nth term of the sequence. So we start with our first rule, which is our explicit rule. And remember that that is a to the n equals our difference times the number of term plus our a sub 0. So my a to the n equals my difference, which is 3, times the number of term I'm on, plus my a sub 0. Well, if my first term is 25, and to get the rest of the terms in my sequence, I'm going to add 3 each time, I want to back up one term, so I'm going to subtract 3 to get my term that's previous to the first term. So 25 minus 3 gives me 22. Now I want to write the recursive rule, and the recursive rule first starts of what is my a sub 1, and then to finish off we write the rule as a sub n is equal to a sub n minus 1, or the previous term, plus the difference. So my a sub 1, that was given to me as 25, and then we have a sub n, or whichever term I'm looking for, take the previous term, and we're going to add the difference, and the difference is 3. In our next example, we have a to the n equals d to the n plus a to the 0 for our explicit rule. Our difference is negative 7, but I don't know what my a sub 0 is. Now there's a couple of ways you could accomplish that. You could start at 6 and know that I have to subtract 7 each time to come up with the numbers in my sequence. I could then back up each time until I get to a sub 0. So instead of subtracting 7, I'm just going to keep adding 7 to get back to those numbers. Or I can fill in the formula to find my a sub 1. Here's what I'll do. A sub n, which means I can take any term I want. Well, I have my fourth term. So what I'm going to do is first of all find my a sub 0. So my a to the n, a to the fourth is 6. My difference is negative 7, and according to my term, I have my fourth term listed. That's my number 4 term. And then that will give me my a sub 0 when I finish solving the equation. So 6 is equal to negative 28 plus a sub 0. So I'm going to add 28 to both sides. And so I have 34 is equal to my a sub 0. That's going to allow me to write my explicit rule. So I have a to the n, I don't know what that is, equals the difference, that was given to me as negative 7, times the term n, plus 34. Now I want to write my recursive rule. So here's what I do. I first write my a sub 1. Well, I don't know what a sub 1 is, but I do know that the term before it is 34. So, since my difference is negative 7, I simply, to find my a sub 1, have to just take 34 and subtract 7. That gives me an answer of 27. Then, to finish the rule, I have a sub n, and that equals a sub n minus 1, plus the difference, and my difference is a negative 7. So, to review, remember that an arithmetic sequence has a constant difference. The explicit form is a sub n equals the difference times the number of the term you're on plus a sub 0, which is the previous term, or the term before your first term. In the recursive form, a to the first, or your first term, is what we start with. And then we have a sub n, or whichever term you're looking for, equals a sub n minus 1, which means the term previous to that, plus the difference. Please complete the reflection.